still about slope and the triangles that you technically draw when you're finding slope when you're counting. So real quick, let's put our Chromebooks, close those, we don't need them. Slope we talked about. Slope is what over what? Rise over run. So I would probably write that back at the top of your paper. Slope is rise over run, which means it's the change in the y over the change in the x. Okay, rise is the y, x is the run. All right, so it says Joe and Kelly are each going to find the slope of this graph shown by comparing the ratio of the rise over the run. Use the graph to answer the questions below about their work. So this graph is what all our answers are going to come from. So number one, in order to find the slope of the graph shown, Joe chose the points 0, 0, and 2, 4 to make a right triangle. Draw this triangle on the graph. So 0, 0, where do I find 0, 0 at?
The origin.
The origin. This is 0, 0 right here. Okay, I'm going to label mine 0, 0 so you can just see where I'm putting it. Okay? And then he also chose 2, 4. Now, when I graph points, points are x comma y. So yes, I know this always is confusing to kids. Slope is rise over run, which is something completely different than ordered pairs. Ordered pairs, you count the x first and then the y, but slope is the y over the x, so they're backwards. So ordered pairs, x comma y, because x comes first in the alphabet. So 2, 4 is 2, 4. So right there, that's 2, 4. And I'm just going to label it so you see it. All right, and then I'm going to draw my triangle. Okay, that triangle that we're drawing is the same way that we counted slope yesterday. So I count slope as rise over run. Ready? So I'm going to rise 1, 2, 3, 4. So I rose 4, and I'm going to run 1, 2. Everybody agree? That's what we did yesterday. So that right there is my triangle. So that was number 1. I drew a right triangle. What's a right triangle even mean? It's got a right angle. What is a right angle? 90 degrees. So it's that perfect like square. Okay, so it says using Joe's triangle, what is the slope of the graph? Well, we started finding the slope when we drew the right triangle because slope is rise over run. So how much did I rise? 4. Because I went up 4. And how much did I run?
2.
Now, would this be a positive or a negative slope based off the line?
Positive.
Because it's going up from left to right. Can 4 over 2 reduce?
Yes.
So what?
2.
2 over 1, which is 2. So using Joe's triangle, the slope is 2. All right, I want you all to do 3. So in order to find the slope of the graph shown, Kelly chose 2, 4, and 5, 10 to make a right triangle. Draw this triangle on the graph. So you all do that right now. She chose 2, 4, and 5, 10. Okay, so 2, 4 is right here, which we just used for Joe, and then 5, 10. So I'm going to go 1, 2, 3, 4, 5 on my X, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my Y. So this is 5, 10. Okay, everybody good with putting the points on there? All right, and then I'm going to draw my triangle. So I'm going to count from that lower point to that higher point. I'm looking at even in this front row, and some of us drew our triangle this way. It does not matter. Okay? If you drew yours like I did, or if you draw it like this, it does not matter. It's still the same because you're still doing the rise over the run. I just always like to count rise first. So I'm gonna rise 1, 2, 3, 4, 5, 6. And I'm gonna run 1, 2, 3. To draw my right triangle. Some people in the front have it drawn this way that I can see, which is completely fine. All right, so it says, using Kelly's triangle, what is the slope of the graph? Well, how much did we rise for Kelly's? And how much did we run? 3. So we did 6 over 3. Well, what is 6 over 3? 2. All right, how are Joe and Kelly's triangles related? Ryan? Both equal the same one. I know, but what is that number called that we got? It's called no, but read it. What was it asking for? What is the slope? So they got the same slope. Okay? And these triangles are proportional. And the reason that they're proportional is because the slopes are the same. And what does the word proportional?
Equal.
Not that they're equal, but they're related, that they're similar, okay? They are similar because their sides are proportional and equal the same ratio. The slopes are the same. So, like if I was to take the triangle up there, they still have the same ratio of 4 over 2 to 6 over 3. They both equal that same slope, which makes those sides proportional. All right, number 6, explain why we can use any 2 points on a line to find the slope of a line. Anybody know why we could use any 2 points? We talked about it yesterday. Remember? Reagan?
Does it matter? It's gonna be the same slope.
Because the slope of the line is, can I know a word for that? The slope of a line is constant. The slope of the line is constant. No matter what 2 points you choose on a line, that positive slope or that negative slope or that flat slope is constant. It will always be the same change in the y over the same change in the x every time I count from one point that perfectly goes through to the other. It will always be the same. All right, it says, based on what you know, which of the following triangles would also lie on the line graphed above? Explain why. So look at these 3 triangles and figure out which one would have the same slope as the other 2, which means they would also lie on the same line. Give everybody a chance to look at it before we tell. So remember, slope is the rise over the run. So we're looking at these 3 triangles to figure out which one has the same slope so that it would go on the same line. Addison? B, does everybody agree?
Yep.
It is B. It is triangle B, and in math, you can always use a little triangle, and we assume that that means triangle B. So triangle B, and the reason triangle B is the same is because what?
36.
Or you could say because it's rise over run, and 36 over 18 is the same as 2. So the slopes are the same. Which means that it would lie on that same line because it would still have the same rise over run. All right, before I go to the back, I'm going to show you all something. Somebody tell me a second. Okay, we said that the slope was 2, right? Okay, I'm going to erase this for a second. Okay, and if I start here, slope is 2. How do I make, slope is always a fraction when you count it. How do I make a whole number a fraction? You put a 1 over it. So if I start here, you ready? Rise over run. So rise 2, run 1. Hey, look, it's another point. Rise 2, run 1. Look, it's a point. Rise 2, run 1. Look, it's a point. So perfectly goes through it. Rise 2, run 1. Rise 2, run 1. That's why they all have the same slope, because if you choose a point that goes perfectly through the corner of the box that's on that line, that slope will be the same over and over and over again. You can count that slope for an infinite amount of times to find so many points that are on that same line. Now, we won't ever graph more than 3. But you could go the other way. Like if I was to extend this out, instead of going up to right 1, does anybody know what other way I could go to make it the same line? Down to left 1. Down to left 1. Down to left 1. And hey, look, it's all part of that same line. So that slope will go on forever in both directions. And that's what we're moving towards here in these next couple weeks, is being able to graph slope on a line. All right, flip it over. Guess I know it's backwards. I don't know what I did. See how it's not? You know what I'm saying? Okay, so I'm gonna let you all do this one. Draw 2 different sized triangles that could be used to find the slope on the graph below. Label the rise over run and then explain the relationship between the triangles. So right now, let's do that first part. You make your own 2 triangles on this graph, and then tell me what the rise over run is for both of them. We're going to compare and see what some people have versus somebody else. So choose your own 2 points for one triangle, and then choose another 2 points for another triangle. All right, hopefully we paid attention to the intervals. Look at the y-axis. What's it counting by?
2.
2's. And what's the x-axis counting by?
1.
1's. All right, who wants to tell me one of the triangles that they drew? Anybody? Blockhead. Or do you want to come here and draw? You want to? You don't have to. You can tell me the points. Nobody's so scared yet. He takes it. All right, good. Okay, good job. Does anybody want to come up and draw another triangle? AF was excited. He about came out of his seat. All right, perfect. Anybody else have one that's different? All right, let's quick. All right, Paul, I'm looking at category. Category. You all blend in together. Talking down, sit next to each other. Yeah. Well, and with you all having masks on, it's hard for us to tell the difference.
I don't like masks. Yeah.
All right, good. So there's 3 examples. Somebody could have maybe done this one right here. Okay, so there's a bunch of different triangles that you could have used. Okay, so let's say we'll just go with the green and blue one because there are people that did theirs first. So this green one, if I count rise over run, 1, 2, 3, 4.
Level. Intervals are 2.
Oh, you're right. Look at me being a dick.
Double.
This wasn't the dingle. Okay, you're right.
Why did you
I know, but here I even said make sure you watch the intervals and look. All right, so once again, 2, 4, 6, 8, and then 1, 2, 3, 4, 5, 6. Yeah, so one, 8 over 6, which reduces to
2/3.
no.
I was.
All right, the blue one. 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 12 over 9, which reduces by 3, to also be 4/3. Okay? And so there's my slope, and it says explain the relationship between the triangles. They're proportional triangles. So they're proportional triangles. And that's the relationship. They're all proportional because they all have the same ratio, the same slope. Let's look at number 9. Were there any questions about that one? All right, number 9, it says, which of the following triangles would also lie on the graph below? Line graph below. Explain your reasoning. So what that means is you're going to have to find the triangle that has the same slope as the line. So what does that mean you should probably find the slope of first? The line.
It's a negative.
And so you're not a dingle like Miss Wilson. Look at the y-axis again. It's counting by 2.
It's a negative though.
And it is, you're right. Yep, you're right. Look at you go.
Good job. But the numbers are positive.
That doesn't have anything to do with it.
It's on a roll today.
I just wait till joggers.
Leave it alone. Alright.
Your forehead's bigger than cake.
Whoa, still dog. See how me?
Whoa.
Whoa,
Guys,
whoa. Push that hair back. Let's see that. Okay, that one's tiny. 42?
We
Look
like
under
growth.
that hair, 42.
Hey, look at Isaac.
Yeah,
Let's see what's under Blake. Let's see what's under Blake. Same.
Let me see, Blake.
You guys have a
I don't have a forehead. My forehead is not a good.
Alright, come on, let's finish then.
You just made fun of people in wheelchairs. You just made fun of physically disabled people.
Your emotions are possible when you cried at the end of Harry Potter 8.
I haven't watched Harry Potter.
Alright, guys. Alright, let's walk us through because we need a little hand holding here. So let's say you choose this point and this point. Now, Blake was right. This is a negative slope because the line is going down from left to right. Alright, so I'm gonna look here. I went down 2 over 1, 2, 3. So my slope is negative 2/3. So I'm gonna look for the one that has the same 2/3 ratio.
Oh, shoot, I picked.
Okay?
Don.
You already know it? What is it?
It's triangle C.
Yeah, I got that right.
So listen. Here's how you would figure that out. Rise over run. So 30 over 50, I'm talking 30 over 55 reduces by 5. So that's 6/11. So that's why it's not that one. 28 over 45, that reduces by nothing because 28 is 4 times 7, 2 times 14, 45 is 9 times 5, that's about it. So that one. And then 26 over 39, that reduces
By 3.
by 13.
Well,
by 13, 26 divided by 13 is 2, 39 divided by 13 is 3. So that's why it's C. And it says explain your reasoning. If you show your work like that, that's enough explanation on why it's that one. If you don't show your work, then you need to say something like triangle C has the same slope as the given line. Like then you have to write something out, okay? But if it does say to explain or why, if you don't, you're only going to get a half credit.
Well, can I put triangle C because it's the only one that reduces to 3.
Which is what I said. The one that has the same slope.
I zoned out.
All right, let's look at 10. So it says circle the triangle that would not lie on the same line as the others.
Hey,
So it wants to know which one does not, which one has a different slope than the other two. So let's all find the slopes quietly. I can also teach you all how to use your calculator to reduce fractions. I'll do that at the end.
No, I got.
You're not going to get it.
what?
I know the answer.
Kind of.
All right, so the rise over the run. So 28 divided by 7. What's 28 divided by 7? 4. 68 divided by 17 is 4. So that's how we know it's this one, because that's the one that would not be, because those are both 4. And then either quiet. So here's one way that you can explain it. You could say that 77 over 19 does not equal 4, so that's one explanation. Or you could write that out in words and say the third triangle does not have a slope of 4. So either way of your explanations, but you need to write it out. All right, we're gonna do the last one together. It says the slope of a line is 1/5. Label the two right triangles that with dimensions that would allow the triangles to lie on the same line. So what that means is if you know the slope is 1/5, you need other numbers that when you simplify them equal 1/5. So I need some equivalent fractions to 1/5. Does anybody have any ideas? All right, Catherine. Huh? Yes. Oh, that's what you're saying. I was like, what? Yeah, you're right. 5 25ths would be perfect because 5 over 25 reduces to 1/5. I don't know what I thought you were saying. Cameron? 2/10. So rise over run. So rise over run also reduces to 1/5. Everybody else got another one? All right, Ryan. 1/5. We can't use 1/5, so I use a different one.
Oh my.
Eli? 315 is Cameron. Yeah.
200,000 over a million.
Sure. I don't know. All right. So
Yeah, I probably did, but I'm like off the hours.
That's not that smart.
I was gonna say you're more like. Never mind.
Where's the Ow. Wait.
Oh, Trevor, what did you say about physically disabled people?